Now for our next circuit, which is actually going to be very similar, we ain't going to have to move much around. We're going to add the capacitor to the circuit. So what we're going to do is we're going to add the negative side of the capacitor to the negative rail straight. Then we're going to add a jumper to the positive side of the capacitor right here over to the positive side of the switch, which looks like I don't have enough area to plug it into. So what I'm going to do is I'm going to unplug the switch on this rail, plug this one in, run it to the positive side of the capacitor, and then I'm going to plug this wire into the positive side also. So I'm just jumping the rail, still the same connection. So now let's look at the connection again. We got a positive wire, this green one, running straight to the switch, so the switch is hot. Then we have an orange wire that's only activated once you hit the switch, running to the capacitor. From the capacitor we have another wire going to the resistor, which limits the amount of electricity that's getting passed through this blue wire to this diode, which then goes through this other blue wire down into the rail. So what do you think is going to happen when I press the switch this time? Please note that there's one other connection, and that's the negative side of the capacitor to the negative rail. If you remember from my previous videos, I referred to this particular type of capacitor, which is an electrolytic capacitor, as almost like a water tower. What happens is it doesn't contain electricity like a battery does, but once you put electricity towards it, it can store the electricity, and then once you shut the electricity off, it can discharge the electricity, and that's actually what takes place in a water tower. A water tower itself does not produce the water, but it has pumps that pump the water up into the tower, and then the tower contains that amount of water, usually under pressure because it's above gravity. And then when, let's say, the pump shut off for 5 minutes and rest, the town doesn't just run out of water. Instead, that water that's reserved inside that water tower is used up during that amount of time. And then when the water comes down to a certain level, the pumps kick back on, the water level comes back up, and it just repeats. And so similarly, that's what this is going to do. But right now it's dead because there's no electricity getting to it. So let's see what happens. I'm going to press this switch. I'm going to hold it down for a few seconds. We see as soon as I hit the switch that the LED comes on. But when I release the switch, the LED stays on, slowly goes out. Let's try that again. When I hit the switch, the LED comes on. I'm holding it down. When I reach the switch right now, it slowly goes down. So why is this actually taking place? Well, similar to that water tower, this is storing up electricity because the resistors are not allowing 100% of the flow to go straight to the diode or the LED. So instead, some of it is being blocked, and as that's being blocked, the pressure builds up inside the water tower, so to speak, the capacitor. As the capacitor fills up, it gets full of the electrons, and when I release the switch, it's still full, so it discharges its electrons through the resistor into the diode, and that discharges the circuit. So I'll try this a few more times. We'll try it at shorter intervals. We'll try 1000. And we see that that still works. So let's try even a shorter interval. That works. So you see it doesn't take very much to charge up a capacitor. In fact, almost as fast as I can hit it, that capacitor still holds that charge. And this is only 5 volts. The capacitor is rated 50 volts, which is really nothing to the capacitor. 5 volts is nothing. And because it's a 1000 UF capacitor, it can hold quite a bit. So let's see what happens again if we was to take the capacitor out of circuit. I just picked it up and lifted it up. Let's try it again. See that it's nearly instantaneous. As soon as I hit the switch, the LED comes on. When I release the switch, the LED goes out. I put the capacitor back in the circuit, hit the switch, and the LED discharges slowly. So if you wanted to make that LED use less electricity, so to speak, you could actually hit it in small pulses, and if you did it fast enough, you'd never notice that you was only using half of the amount of energy was being conducted through that switch and through these wires. Same amount of electricity is being used because it's being stored in the capacitor and then discharged, but the actual load on the wires itself is less. So that concludes this lesson. Tune in next time for the next lesson.